A world of rock and dust lay silent under a harsh sun. This was Earth before the first rain, a planet without a single river or lake. We are uncovering the mystery of how that first rainfall changed everything, triggering the birth of rivers, lakes, and life itself. By the end, you will understand the true origin of the water that defines our world and makes our existence possible. We will explore the cataclysmic events that filled our skies and sculpted our continents. What does it mean that our entire living world began with a single drop? That initial landscape was a planet of contradiction. Its sky, a thick blanket of steam and carbon dioxide, actually held immense amounts of water, but in a form completely useless for life. Every molecule was trapped as vapor, suspended in the scorching air above a crust that was still cooling from its molten birth. Jagged mountains of black rock reached for a hazy, orange sky, their surfaces unmarked by any flow except for occasional rivers of lava. There were no gentle slopes carved by streams, no smooth valleys, no pebbles rounded by tumbling water. Every cliff and chasm was sharp, raw, and new, a testament to a world built solely by fire and violence. Erosion, the patient sculptor of our modern Earth, did not exist here. The very idea of a puddle, let alone an ocean, was a physical impossibility. This global desert, silent except for the rumble of volcanoes, was the ultimate blank canvas. It was a stage set for a single, monumental event, a transformation that would not arrive with a cataclysmic bang, but with a slow, relentless drop in temperature. The planet was finally cooling down, and that simple change of state was about to unlock the water hidden in plain sight, initiating the very first weather system the world had ever known. This great cooling was a planetary sigh of relief. For millions of years, the thick atmosphere had acted like a stifling blanket, trapping the sun's heat with terrifying efficiency. But as the planet's fiery interior calmed and the crust hardened, that thermal energy began to slowly dissipate into the void of space. The temperature did not plummet, it crept downward in an almost imperceptible decline over vast stretches of time. This was not a dramatic event, but a silent, invisible shift. The key player in this drama was the countless trillions of water vapor molecules buzzing in the hot air. For eons, they had possessed too much energy, moving too fast and colliding too violently to ever stick together. They were perpetual individuals in a frenzied crowd. But as the ambient warmth faded, so did their frantic speed. Their motion slowed from a sprint to a jog and then to a walk. They were finally approaching the moment when a simple nudge, a collision with a speck of dust or a cool pocket of air, would be enough to make them cling to one another. This was the crossing of a crucial threshold, the invisible line between a gas and a liquid. The stage was set not for a single raindrop, but for a phase change of planetary proportions. The atmosphere itself was about to turn inside out, releasing the ocean it had held hostage in the sky. The first chapter of Earth's story, written entirely in fire, was closing. The next was about to be written in water, and it would begin with a single, fateful condensation. It began with a single, microscopic alliance. High in the cooling atmosphere, a lonely molecule of water vapor drifted until it brushed against a tiny, floating speck of volcanic ash. That minuscule grain of dust became an anchor, a solid surface in a formless sky. Other vapor molecules, slowed by the deepening chill, were drawn to this new foundation. They clustered around the speck, pulled together by an invisible molecular glue known as surface tension. This was not yet rain. It was the birth of a droplet, the very first of its kind. That one fragile sphere of liquid water represented a revolution in the state of matter. The sky was no longer just holding water, it was beginning to release it. And this process did not happen just once. It happened again and again and again, 1,000,000,000,000 times over in a silent, global chain reaction. Each new droplet formed around a similar nucleus, a mote of dust or salt or smoke, each one a testament to the power of a simple seed. What started as a solitary event became a collective transformation. The atmosphere, once a holding tank of vapor, was now a factory for liquid water. The energy released by this phase change, the shift from gas to liquid, further fueled the cooling process, creating a runaway effect. The stage was now set for the next inevitable act. These individual droplets were still too small and light to fall. They hung suspended, gathering more moisture, colliding and merging with their neighbors. They were growing, and as they grew, they began a slow, collective descent that would build into the first storm the world had ever seen. That microscopic alliance in the sky became a planetary revolution. The atmosphere, once a holding tank, reached its breaking point and unleashed a global torrent. This was not a gentle shower. It was a ceaseless, vertical ocean falling from the sky, a downpour that may have continued for thousands of years without a single break in the cloud. The first raindrops struck a world of hot, barren rock. They did not soak in or form puddles, they exploded. Upon impact with the scorching surface, the water instantly flashed back into steam, creating a vast, seething blanket of mist that rose only to cool and condense once more, fueling the endless storm above. This created a violent, self-perpetuating cycle of falling and rising water, a planetary engine of condensation and evaporation. The sound would have been unimaginable, a deafening, relentless roar that echoed across every continent, the first weather sound on a planet that had known only silence and volcanic rumble. This was the true birth of the hydrological cycle, the moment water began its eternal journey from sky to land and back again. That endless rain was the sculptor's first tool, and the blank canvas of rock was ready to be carved. The first river did not begin with a gentle trickle. It was born from a chaotic overflow, a sudden escape of pooled rainwater that could no longer be contained on a saturated slope. This was not the clear, meandering stream we might picture today. It was a thick, gray-brown torrent, heavy with pulverized rock and volcanic ash, a liquid sandpaper grinding relentlessly against the primordial landscape. Where the rock was soft or fractured, the water clawed and dug, turning a minor depression into a groove, the groove into a trench, and the trench into a deep gully. You can think of it as a sculptor finding a crack in a massive block of stone and focusing all its effort there, not with a chisel but with an endless, abrasive slurry. This was the dawn of fluvial erosion, the fundamental process that would one day carve the immense scale of the Grand Canyon and shape the vast basin of the Amazon. That first tentative flow proved a simple, unstoppable principle. Water always seeks the path of least resistance, and in doing so, it forges the very paths that define a continent. Each grain of sediment carried in its current was a tiny tool, scouring and smoothing the raw, jagged edges of a world built by volcanoes. This was the planet's first lesson in landscape architecture, taught by a relentless, flowing force. And as these new riverbeds deepened, they began to guide all the water that followed, channeling the endless rain toward a common destination, setting the stage for the creation of the first great collections of water on Earth. Those first rivers carved deep channels, but their journey had to end somewhere. The relentless runoff, guided by gravity, began to seek out and fill every low point on the young planet's surface. Where the topography created natural basins and depressions, the flowing rainwater could no longer escape. It began to accumulate, no longer just passing through but settling to form the planet's very first lakes. Imagine the largest puddle you have ever seen, then multiply its scale to cover entire valleys, creating vast, landlocked seas of fresh rainwater. These were not the clear, tranquil bodies of water we know today. They were likely acidic, murky pools, stewing with a potent cocktail of dissolved minerals leached from the freshly eroded rock and charged with volcanic gases like sulfur dioxide. The water would have been warm, perhaps even hot in some volcanic basins, and colored a milky gray or rusty orange from the suspended sediments. Yet, for all their harshness, these lakes represented a monumental shift. They were the first major reservoirs of standing water on Earth's surface, crucial catchments in the new global water cycle. For the first time, water was not just a transient force carving the land, it was a permanent feature resting upon it. The creation of these lakes provided the first stable aquatic environments on the planet. In the chaotic, ever-changing world of falling rain and flowing rivers, these basins became places of relative stillness. Here, suspended particles could finally settle, and the relentless churning could subside. This stability, this newfound calm, would become the essential cradle for the next great revolution on our planet. Within these murky, mineral-rich waters, the stage was quietly being set for a revolution not of geology, but of biology. These murky, mineral-rich lakes became the planet's first laboratories. Within their deepening waters, a remarkable chemical cocktail began to brew. For eons, the raw ingredients for life had been accumulating, forged in the hearts of stars and delivered to Earth by ancient comets and asteroids. Now, the endless rain washed these organic molecules from the atmosphere and the newly carved landscapes, channeling them into these vast, still basins. The water itself leached more crucial compounds from the surrounding volcanic rock, creating a rich and complex mixture often called the primordial soup. This was not a clear broth, but a thick, nutrient-dense slurry, a concentrated environment where the building blocks of existence could finally mingle. The deepening water column provided a second critical function. It acted as a natural shield, protecting these fragile organic compounds from the sun's intense, sterilizing ultraviolet radiation. On the barren surface, such complex molecules would have been quickly torn apart, but here, submerged and safe, they were granted the stability and the time they desperately needed. In this aqueous sanctuary, dissolved amino acids, lipids, and nucleotides could drift for centuries, bumping into one another, forming new and ever more intricate alliances. The water was the perfect medium, allowing for constant movement and interaction without the destructive energy of the surface world. This nurturing environment set the stage for the most profound leap in our planet's history. It was here, in the quiet, protected depths of these first lakes, that chemistry began its slow, patient dance toward biology. The scattered ingredients were now concentrated in a safe, liquid cradle, awaiting only a spark of organization to begin the journey toward a living cell. This indispensable nursery suggests a humbling truth. Without the collection of rainwater, without the formation of these first lakes and oceans, the building blocks of life might have remained forever scattered and isolated. The very spark of existence required a vessel to catch it, a cradle built by the first rains. That primordial soup needed more than just ingredients. It needed a chef, and the early Earth provided two of the most powerful ones imaginable. Above the churning lakes, the sky was a constant, violent spectacle. The atmosphere, thick with water vapor, carbon dioxide, and belches of volcanic gas, was a perfect engine for generating colossal storms. These were not mere thunderstorms, they were planet-spanning electrical events. The air itself crackled with a tension that could only be released in shattering forks of lightning, each one a temporary star hotter than the surface of the sun. Every bolt that lanced from the sky into the water or struck the land delivered a massive, instantaneous jolt of pure energy. This was not a gentle simmer, it was a series of cosmic hammer blows. Down in the mineral-rich lakes, this electrical fury found a partner. On the seafloor, in the zones where the planet's thin crust was still cracking open, hydrothermal vents spewed superheated, chemical-laden water into the depths. These were natural, underwater furnaces, providing a constant geothermal heat that kept the surrounding waters warm and swirling with nutrients. Together, the chaotic lightning from above and the steady volcanic heat from below created an environment of immense and varied energy. This energy acted like a universal catalyst, violently shaking the simple molecules in the water. It was this relentless jostling that provided the push, the activation energy, needed to force those simple compounds to link up. A jolt of electricity or a surge of thermal energy could break old chemical bonds and forge powerful new ones, transforming a handful of simple atoms into a more complex amino acid, or perhaps even a nucleotide, the fundamental unit of genetic material. These energetic events were not creating life itself. Think of it instead as a chaotic kitchen where the raw flour, water, and eggs were being violently, randomly mixed and baked by these immense forces of nature. Most of these new, complex molecules would have been instantly torn apart again, but in a world of constant, frantic experimentation, a few of the more stable arrangements would persist. They were the first successful recipes, the building blocks that would prove sturdy enough to survive and interact further. This chaotic energy input was the essential, driving force that pushed the probiotic world across a critical threshold, from a scattered collection of chemicals toward the organized complexity that would one day become a living cell. Deep within those sheltered, mineral-rich waters, a new kind of order began to emerge from the chemical chaos. The first living things were not monsters or even microbes as we know them today. They were something far more humble, the ultimate pioneers. They were likely simple proto-cells, little more than tiny, fragile bubbles of oily lipids that formed a protective membrane. This membrane was their entire world, a delicate barrier that created a crucial distinction for the very first time, the difference between a self and the outside environment. Inside this tiny sac, a unique and concentrated chemistry could unfold, shielded from the endless dilution of the vast lake. These were the first individuals. They did not breathe oxygen, for the world was still utterly devoid of it. Instead, they were anaerobic, drawing their life energy not from the sun or the air, but directly from the chemical soup around them. They feasted on the pre-made organic molecules that the lightning and vents had cooked up, or they harnessed energy from reactions between the rich dissolved minerals like iron and sulfur. Their entire existence was a slow, silent metabolism, a set of chemical reactions contained within that all-important membrane, and every single part of this fragile process was utterly dependent on the liquid water that surrounded them. The water was their universe, their bloodstream, and their shield. It carried nutrients to their walls, dissolved the waste products away, and cushioned them from the harsh realities of the surface world. This emergence marked the single most important threshold our planet has ever crossed. Earth was no longer just a ball of rock governed by geology and chemistry alone. In an instant, on a cosmic timescale, it became a biogeochemical planet. Life itself became a new geological force, a quiet, microscopic tenant that would one day learn to remodel the entire house. The destiny of the world was now shared between the slow grind of tectonic plates and the rapid, replicating spark within a droplet of water. these first organisms, so simple and seemingly insignificant, held within their fragile membranes the blueprint for everything that was to come. They were the first sentence in the story of biology, and their evolution was about to write a plot twist that would transform the atmosphere, the oceans, and the very future of the planet itself. But that quiet, microscopic revolution in the water was about to trigger a planetary crisis. A new kind of microbe had evolved in those sheltered lakes, one that possessed a miraculous ability. These were the cyanobacteria, and they had learned to capture the energy of sunlight itself. Their process, photosynthesis, was a biological marvel. They used the sun's power to create their own food from water and carbon dioxide, but this new recipe had a dangerous byproduct. As they fed, they released a corrosive, highly reactive gas into the water, a waste material that was pure poison to almost every other living thing on the planet. They were exhaling oxygen. At first, this was not a problem. The vast oceans and lakes were full of dissolved iron and other elements that greedily reacted with the oxygen, locking it away in rust that settled to the seafloor in thick, banded layers we can still see in ancient rock formations today. For millions of years, the world acted as a giant chemical sponge, soaking up this toxic exhaust. But the cyanobacteria were relentless. Their populations exploded, forming vast, slimy mats in the sunlit shallows, and they kept producing more and more oxygen. Eventually, they overwhelmed the planet's ability to absorb it. The sponge was saturated. The gas began to bubble out of the water and into the atmosphere, initiating the Great Oxidation event. This was not a single day, but a slow, geological suffocation of the ancient world. The methane-rich haze that had kept the planet warm was torn apart by the reactive oxygen, causing a global deep freeze, perhaps the first snowball Earth. For the anaerobic life that had ruled the planet, this was an absolute catastrophe. Oxygen was a deadly pollutant that ripped apart their delicate cellular machinery. Most of them were driven to extinction, surviving only in isolated, oxygen-free pockets deep underground or in murky sediments. Their world had been utterly destroyed by the waste products of a rival life form. Yet this biological pollution crisis was the very event that made our world possible. The new oxygen atmosphere created a protective ozone layer high above, shielding the surface from harmful radiation. More importantly, it unlocked a far more efficient way to produce energy. Oxygen is a powerful fuel, and the evolution of organisms that could harness it for respiration paved the way for larger, more complex, and energetically demanding life forms. Every breath you take is a direct result of that ancient microbial revolution, a transformation born in the water-filled basins created by the first rains. This profound feedback loop reveals a stunning truth. The rain carved the lakes cradled the microbes, and the microbes then rewrote the very composition of the sky, proving that life is not just a passenger on this planet, but an active architect of its destiny. Those river systems were not isolated events. They multiplied, branching and connecting until they wove a continent-spanning web of flowing water. This was the birth of the planet's first true circulatory system, a network of arteries and veins that pumped not blood, but liquid rock and life, giving nutrients across the globe. Rivers became the undisputed masters of erosion. Their power lay not just in the water itself, but in the immense cargo they carried. Every river was a conveyor belt, grinding down mountains grain by grain, transporting pulverized rock, sand, and dissolved minerals from the highest peaks down to the coastal plains. This was a planetary-scale leveling project, operating with a patience that defies human comprehension. Over millions of years, these sediment-laden flows carved the iconic landscapes that define our world. They sculpted the sweeping curves of valleys and the dramatic cliffs of canyons. When the rivers finally met the sea, they dropped their heavy loads, building vast, fertile deltas that fanned out into the shallow coastal waters. This relentless transport did more than just shape the scenery. It became a crucial, silent regulator of the planet's climate. The weathered rock particles and the dissolved minerals, once they settled on the seafloor, began to slowly bind with carbon dioxide from the atmosphere, locking it away into layers of sedimentary rock like limestone. This process, the long-term carbon cycle, acted as a geological thermostat, gradually pulling greenhouse gases out of the air and helping to stabilize the global temperature over immense stretches of time. The very existence of these intricate river networks, born from that first rain, fundamentally dictated the shape of the continents and the chemical balance of the atmosphere, creating the dynamic and diverse stage upon which the later acts of life's grand story would unfold. These stable lakes became the planet's most creative workshops. Over millions of years, they transformed from simple chemical soups into intricate, layered worlds. Sunlight penetrated the upper waters, fueling forests of algae, while the dark, cold depths below held their own unique mysteries. Each lake, isolated by surrounding mountains or vast plains, became a sealed evolutionary laboratory. Within their bounded waters, life was free to experiment without constant competition or interference from the outside world. A small population of fish or crustaceans, once trapped in a lake, could branch into dozens of new forms, each perfectly adapted to a specific niche, a particular depth, or a unique food source. This process of speciation in isolation is how a single body of water can become a cradle for life forms found nowhere else on the planet. Consider the vast, ancient lake Megachad, which once covered a central part of Africa. Its fertile waters and shorelines supported a thriving ecosystem, a green jewel in a dry world that served as a vital refuge and a hub for countless species. Or look to the deep, cold waters of Lake Baikal in Siberia, the oldest and deepest lake on Earth. Its immense age and stability have allowed evolution to craft an almost alien menagerie, including translucent fish and the world's only species of freshwater seal. These are not mere curiosities. They are living proof of the creative power unleashed when water is given a permanent home. Beyond their role as evolutionary cradles, lakes served as the very anchors for life on land. They became essential way stations for vast animal migrations, offering rest and refreshment to herds crossing arid landscapes. For every creature living on the shores, from the smallest insect to the largest predator, the lake was an unwavering source of life-giving fresh water. They even acted as natural climate buffers, their massive volumes of water absorbing heat in the summer and releasing it slowly in the winter, moderating the local environment and providing a haven during times of climatic stress. Every one of these diverse, vibrant ecosystems, from the smallest pond to the largest inland sea, traces its lineage back to that first collected rainfall. The simple act of water pooling in a basin did more than just create a habitat. It built a stage for endless experimentation, granting life the time and stability it needed to specialize, to diversify, and to flourish in a breathtaking explosion of forms. While rivers carved the surface and lakes pooled in the basins, another, more secret journey was taking place. Much of that primordial rainwater never made it to the ocean. Instead, it began to seep downward, percolating slowly through cracks in the volcanic rock and filtering through porous layers of sand and gravel. This was a patient, invisible migration, a drop-by-drop descent into the darkness that would accumulate over millennia, filling the hidden spaces within the Earth's crust. These vast, underground storehouses became the planet's first aquifers, the largest single reservoir of liquid freshwater on Earth. Think of the ground beneath your feet not as solid rock, but as a giant, complex sponge saturated with water that fell from the sky thousands or even millions of years ago. This was the birth of a hidden world, a subterranean ocean completely separate from the lakes and seas above. The formation of these aquifers introduced a crucial delay into the water cycle. Water that might have rushed to the sea in a matter of weeks was now stored for centuries, creating a deep time savings account for the entire planet. This hidden water wealth became a lifeline for the world above. During periods of drought, when surface rivers shrank and lakes evaporated, these underground reserves would slowly release their water, feeding springs that bubbled up to sustain river flows and keep valleys green. They also provided the only source of water for deep-rooted plants, allowing the first forests to establish themselves far from any visible stream or lake. The very resilience of continental ecosystems, their ability to weather climatic shifts and dry spells, was underwritten by this deep, slow-moving water. The legacy of the first rain, therefore, is not just written in the canyons and coastlines we can see. It exists in a hidden dimension, a testament to the planet's profound foresight, ensuring that the gift of water would not be fleeting, but locked safely away in a vault deep beneath our feet. This great planetary engine is still running today, powered by the same simple, relentless physics. Every time you see a cloud form or feel a drop of rain, you are witnessing a direct continuation of that first, world-changing storm. The water cycle became Earth's most vital circulatory system, a continuous loop of evaporation, condensation, and precipitation that has never stopped. It functions as the planet's primary climate regulator, capturing heat from the sun at the equator. This thermal energy is then transported through the movement of water vapor in the atmosphere, distributing warmth toward the poles and moderating temperatures across the globe. This vast, invisible conveyor belt of moisture is what generates our weather patterns, from gentle breezes to the mightiest hurricanes, all driven by the sun's power lifting water from the oceans. This endless journey is also the ultimate recycling program. The same water that carved the first riverbeds billions of years ago is falling on your head today. It has been inside dinosaurs, frozen in glaciers, and suspended in clouds over lost continents. The system constantly purifies and redistributes Earth's most precious resource, ensuring that fresh water is continually delivered to the land. Every lake is refilled, every aquifer is recharged, and every plant is watered by this ancient, unbroken process. This means the very existence of a forest, a city, or a farm is entirely dependent on a cycle that began when the planet first cooled. The rain was never just a one-time event that filled the oceans. It was the ignition of a perpetual motion machine that has sustained the living world ever since, connecting every single drop of water in a timeless planetary dance. That relentless flow of water did more than just carve the land. It also began to write. As rivers lost their energy upon reaching the calm of a lake or the vastness of an ocean, they could no longer carry their immense cargo of ground-up rock. The suspended particles, from the finest silt to coarse sand and gravel, began to settle out, drifting down to the bottom in a slow, constant rain of sediment. Layer upon layer, year after year, these deposits accumulated, each new stratum burying the one beneath it. Over immense stretches of time, the sheer weight of the overlying material compressed the lower layers, squeezing out the water and cementing the loose grains together into solid rock. This is how sandstone and shale were born, not from volcanic fire, but from the patient, stacking work of water. These sedimentary rocks became the planet's own archives, the ultimate history books written in stone. Within their stratified pages, they captured moments of deep time. A sudden layer of coarse gravel might tell the story of a catastrophic flood. The fine, even grain of a shale layer speaks of a long period of quiet, deep water deposition. And crucially, these rocks became the perfect tomb for the remains of early life. When a shell or a bone settled into the soft mud, it could be sealed away from decay, its form slowly replaced by minerals, creating a fossil. This process preserved not just the organisms themselves, but also chemical signatures that act as proxies for ancient climates, telling us the temperature and composition of the water and air from billions of years ago. Every cliff face of banded sandstone, every slab of fossil-rich shale, is a direct result of that first rainfall. The water that carved the canyons also provided the ink to record the story, giving us the only true record of how a world of barren rock became a living planet. That hidden water wealth below our feet was mirrored by a far vaster reservoir on the surface, one that began to dictate the very rhythm of the planet. The emergence of the global ocean introduced a powerful new force, a planetary thermostat built from liquid itself. Water possesses an almost magical ability to absorb and store heat without quickly changing its own temperature. This high heat capacity meant the nascent oceans could act as a massive thermal battery for the entire world. During the day or in the hot summer months, the seas would soak up immense amounts of solar energy, preventing the land from becoming a scorching inferno. Then, during the night or the cold of winter, the oceans would slowly release that stored warmth, keeping the climate from plunging into a deep freeze. This simple physical property of water created a buffering effect, smoothing out the extreme temperature swings that would otherwise tear a world apart. It is the reason why a desert with no large body of water can be blisteringly hot by day and frigid by night, while a coastal city enjoys much milder and more stable conditions. This moderation provided the consistent, predictable environment that complex life forms needed to evolve. Beyond this local buffering, the water cycle itself became a global heat distribution engine. The sun's energy is strongest at the equator and weakest at the poles. Without a way to move this heat around, the tropics would boil and the poles would remain permanently locked in ice. But water provides the solution. The sun's heat evaporates ocean water at the equator, pumping vast amounts of energy-rich water vapor into the atmosphere. This warm, moist air then travels toward the poles, and as it cools and condenses back into rain, it releases that captured heat into the higher latitudes. This endless process of evaporation and condensation acts like a massive, planet-wide conveyor belt, tirelessly moving thermal energy from where there is too much to where there is too little. It is the engine that drives our weather patterns, from gentle rains to powerful hurricanes, all in service of balancing the planet's temperature. This newly established hydrosphere created a climate of remarkable stability, a stark contrast to the wild, lethal temperature swings seen on a waterless world like Mars. That stability was the greatest gift the oceans could give. It provided the consistent, nurturing conditions that allowed life to not just cling to existence, but to experiment, to diversify, and to flourish for billions of years. The rain did not just fill the oceans, it gave the planet a heartbeat, a steady, reliable rhythm that made long-term evolution possible. This deep, ancient connection between water and life extends directly into the story of us. From the very dawn of humanity, our ancestors were instinctively drawn to the life-sustaining gifts of freshwater. They did not wander randomly, but followed the paths of rivers and gathered around the shores of lakes, establishing their first permanent settlements in these vital oases. The great rivers of antiquity, the Tigris and Euphrates, the Nile and the Indus, were far more than just sources of drinking water. They became the active cradles of civilization itself. Their predictable, seasonal floods were not disasters to be feared. but eagerly anticipated events that deposited layers of rich, fertile silt across the floodplains, creating the perfect conditions for the birth of agriculture. This was nature's own farming system, a yearly gift of renewed soil that allowed for the cultivation of surplus crops like wheat and barley. That surplus was the fundamental breakthrough. For the first time, not every member of a society had to spend their days searching for food. This new stability freed people to specialize, to become artisans, priests, soldiers, and scribes. The rivers also provided the first highways, allowing for the transport of goods, ideas, and people across vast distances, fostering trade and cultural exchange. The very rhythm of these early societies was dictated by the water. Their calendars were based on the flood cycle, their gods were often deities of the river or the rain, and their survival was a direct negotiation with the water level. The story of Mesopotamia, of Egypt, of the Indus Valley is not a separate human history. It is the latest chapter in a planetary saga, a direct continuation of the geological and biological processes set in motion by the first rains. Our own civilization was built directly upon the hydrological foundations laid down over 4 billion years, a profound testament to our species' enduring and inescapable dependence on this ancient, recycled resource. Our deepest cultural stories are written in water. Long before we understood the science of condensation, humanity looked to the sky and saw a divine hand at work. The relentless, life-giving power of rain was too immense to be a simple accident of nature, so our ancestors gave it a name and a face. In Mesopotamia, the god Enlil was the lord of the storm, his breath alone capable of conjuring the tempest that would either nourish the fields or wash them away. In the Vedic traditions of India, the warrior god Indra wielded a thunderbolt, using it to shatter the demon Vritra and release the waters locked within the clouds, a mythic battle that mirrors the scientific breaking of a drought. And for the Aztecs, the goggle-eyed Tlaloc was not merely a rain god, he was a being of immense complexity. He could provide the gentle showers that made the maize grow, but he also commanded the destructive power of hail and lightning. To anger Tlaloc was to risk drought and famine, but to honor him was to invite prosperity. These deities were never simple, kind-hearted providers. They were capricious, powerful, and demanding, reflecting the very real and terrifying uncertainty of the natural world. A season without rain meant death, and so these stories became a framework for understanding and, more importantly, for pleading with the forces that held their lives in the balance. The creation of a rain god was an act of profound hope, an attempt to bring a chaotic and terrifying force into the realm of negotiation through prayer and sacrifice. This global impulse to personify the rain reveals a universal, intuitive truth that predates modern science by thousands of years. Every culture, in its own way, recognized that the descent of water from the heavens was the fundamental act of creation. The Aboriginal Dreamtime stories tell of ancestral beings who shaped the land and left water in their tracks. The Babylonian epic Enuma Elish describes a primordial world of watery chaos from which all order emerged. These myths are not mere fantasies. They are the human echo of a planetary memory, a narrative recognition that the first rain truly was a Genesis event, the moment the world became alive. Our oldest stories, carved not in stone but in the collective human consciousness, remember the beginning not as a world of fire, but as a world born from water. Modern hydrology reads the water's own memoir. Using tools our ancestors could never have conceived of, scientists can now trace the precise age and journey of a single water molecule. They analyze the unique isotopic signatures within it, which act like a natural timestamp and travel log. This reveals if a sample of deep groundwater fell as polar ice 20,000 years ago, or if the water flowing from your tap began its descent in a storm over a distant ocean. We can track a river's entire course from a mountain spring to the ocean delta using satellite data and chemical tracers, watching in real time as it merges with other flows and gradually changes character. This profound understanding does not strip away the mystery of the water cycle. Instead, it replaces ancient superstition with a far deeper reverence for a system of sublime complexity. Every aquifer is a living archive, every raindrop a page in a continuing epic. By deciphering these hidden pathways, we are reading the latest chapter in the story that began with that first cataclysmic downpour. This knowledge illuminates the delicate, dynamic balance that keeps our world alive, showing us that the same water that carved the Grand Canyon and filled the first lakes is still here, still moving, and still utterly essential to every breath we take. Our own planet's story has become a guidebook for exploring the cosmos. The fundamental rule in the search for alien life is a simple one: follow the water. We now scan other worlds not for little green men, but for the familiar geological signatures that water leaves behind. On Mars, our rovers are not merely crossing a desert, they are reading the ghostly impressions of a lost world. They traverse ancient, dried-up river deltas and circle the haunting outlines of vast lake beds that have been silent for billions of years. The rust-colored soil under their wheels was once the bottom of a standing lake, a place where, just like on early Earth, the ingredients for life could have once mingled in quiet water. This search for past water on Mars is a search for a planet that might have once shared our own history, a world that cooled, condensed, and perhaps even nurtured life before its atmosphere thinned and its waters vanished. But the hunt does not end with dusty, fossilized shorelines. Our solar system holds even more tantalizing targets. Far from the sun, in the frigid darkness, the moons Europa and Enceladus are frozen over. Their icy crusts, however, are not solid tombs. They are the lids on deep, global, subsurface oceans. The constant gravitational tug of war from their giant parent planets keeps their rocky cores warm, melting the ice from within and creating vast, dark seas that may have existed for most of the solar system's history. We have seen the proof ourselves in stunning images from spacecraft of enormous geysers erupting from Enceladus's south pole, spewing water vapor and organic molecules directly into space. To find liquid water on another world would be to find a place that has crossed the same transformative threshold our own planet did. It would mean that the cosmic recipe for creating a living world is not unique to Earth. This quest turns our own history into a cosmic roadmap, a set of instructions written in water for how to find company in the universe. This ancient water flowing from your tap is a finite legacy. The total amount of freshwater on our planet has not changed since those first storms filled the primordial basins. Every single drop we possess is constantly recycled, used by countless generations of life, and then purified through the great planetary engine of the water cycle, but it is never, ever replaced. We are drinking the very same water that once pooled in the first lakes and flowed in the rivers that carved the continents. This reality forces a profound shift in perspective. We do not create water, we merely borrow it from a closed-loop system that has operated for billions of years. Our modern world, however, places this ancient inheritance under a siege it has never before faced. We contaminate it with industrial chemicals and agricultural runoff. We pump it from underground aquifers faster than the rains can possibly hope to refill them, and we are altering the very climate patterns that govern its distribution. The historical rhythms of rain, the reliable monsoon seasons and steady snowfall that fed our great rivers, are becoming unpredictable, leading to devastating floods in one region and crippling droughts in another. Understanding that every glass of water is a direct, recycled relic from the planet's fiery infancy fundamentally changes our relationship to it. This is not a limitless resource for our taking, but a precious, singular inheritance passed down through geological time. Our responsibility shifts from one of simple consumption to one of active stewardship. The future of our cities, our agriculture, and our civilization hinges entirely on our collective wisdom in managing this gift. The incredible journey of each water molecule, from the first cloud to the dinosaur's thirst to your kitchen sink, demands nothing less than our deepest respect and most careful protection. The rhythm of falling rain dictates the planet's pulse of life. This ancient cycle is the invisible architect of Earth's most vibrant landscapes, carving out distinct worlds based on a simple, relentless variable: water. Where warm, moisture-laden air rises and condenses in a near-constant deluge, it creates the ultimate biological furnaces, the tropical rainforests. In the Amazon basin and the Congo, rain is not an event but a permanent state of being. This unending supply of water fuels a frantic, competitive race for sunlight, resulting in a multi-layered canopy that houses over half the world's known species in just a few % of its land area. Every leaf, every vine, and every specialized creature, from the tree-dwelling frog to the stealthy jaguar, exists as a direct consequence of that predictable, abundant rainfall. Shift the pattern slightly and an entirely different ecosystem emerges. In the savannas of Africa, rain arrives not as a constant but in dramatic seasonal bursts. This cycle of wet and dry imposes a different kind of order. It creates a landscape of grasses and widely spaced trees, a stage for the greatest mammal migrations on Earth. Herds of wildebeest and zebra chase the retreating rains, their very survival tied to the greening of the plains after a storm. The specific timing and amount of precipitation act as a master gardener, deciding which seeds will sprout, which animals will thrive, and ultimately, what the face of the land will be. From the dripping moss of a temperate rainforest to the sun-drenched chaparral, each biome is a unique expression of a local water budget. This direct link reveals a humbling truth: the planet's breathtaking diversity is not a random collection of life. It is a living tapestry woven on a loom of falling water, a pattern established in the deepest past that continues to dictate the richness of our world today. The proof of this great transformation is etched into the very bones of the planet. Our oldest rocks are not mute, they are archives, and we have learned to read their unyielding language. In places like the Isua Greenstone Belt in Greenland, we find stone that is over 3.8 billion years old. This is not volcanic rock born of fire. It is sedimentary, a telltale sign that it was laid down layer by patient layer in standing water. These ancient formations are the first photographs of Earth with an ocean, the ultimate geological confirmation that the rains had come and the basins were full. But the story gets even more specific. Look closely at these ancient surfaces, and you can find the ghostly impressions of ripple marks, identical to those you might see on a sandy lake bed today. That simple, wavy pattern is a fossilized moment, a snapshot of a current flowing over a soft sediment floor billions of years ago. It is direct physical proof that water was not just present, it was moving, carving, and shaping the land in a way we would instantly recognize. Then there are the banded iron formations, stunning stripes of red and gray rock that span entire regions. These spectacular layers are the chemical signature of the great oxidation event. They formed when the first photosynthetic microbes living in those ancient seas began pumping oxygen into the water. That oxygen immediately reacted with dissolved iron, rusting it out of the seawater and causing it to settle to the bottom in rhythmic, rusty bands. These rocks are the literal fallout from the biological revolution that water made possible. Together, this evidence builds an undeniable case. The ripple marks testify to the flow, the sedimentary layers testify to the pooling water, and the banded iron testifies to the life that followed. This rocky trilogy provides the hard data, the factual backbone for the epic of the first rain, confirming the sequence of events that turned a barren world into our living blue marble. That same ancient water now flows within your own veins. Every cell in your body is a tiny, aquatic world, a miniature descendant of those first protected pools. The very blood in your arteries is a saline solution remarkably similar to the composition of the early oceans. This is not a poetic metaphor, but a biochemical fact. The water you drink today was once a cloud in the sky of a dinosaur, a drop in the first river, and a molecule suspended in the steam of the planet's fiery youth. We are not merely inhabitants of this world, we are walking, breathing embodiments of its most ancient history. This shared, recycled essence forges an unbreakable bond with every other living creature. The same water that hydrates the towering redwood tree hydrates you. The same water that once quenched the thirst of a saber-toothed tiger now fills your morning coffee. This realization dissolves the illusion of separation, revealing a deep, intrinsic kinship with the entire web of life. We are all temporary vessels for this ancient, cycling substance, participants in a story far grander than any single lifetime. This perspective fosters a powerful sense of cosmic belonging. You are made of stardust, yes, but you are also made of primordial rain. Your existence is a direct continuation of the same processes that filled the first lakes and cradled the first cells. This humbling truth invites a shift in identity, from being an observer of nature to recognizing that you are an expression of it. You are the universe becoming conscious of itself, a chapter in a continuous, billion-year-old narrative of transformation that began with a single, simple drop. From that first, solitary drop condensing on a speck of dust to the vast, interconnected systems we know today, the story of the first rain is truly the story of Earth's greatest transformation. This single event set in motion a chain of planetary engineering that is still unfolding. The water that fell from that primordial sky did not just passively fill the oceans, it actively sculpted the continents, carving the very stage upon which the drama of life would play out. It provided the stable, liquid cradle where scattered chemical ingredients could concentrate and interact, shielded from a hostile world, until they sparked into the first fragile life. Every stream we paddle, every lake we admire, and every glass of water we drink is a living relic of that Genesis event. This